Formatting of numbers and equations. I was originally going to include this as just a few slides in another video, but I've decided this is such a big problem in science and engineering that I wanted to create its own video. And that is how we properly format numbers, math, and equations when we're producing a professional document. And my experience when I visit conferences and read papers is that us scientists and engineers have very little clue what we're doing here. So please watch this video and format your numbers and equations correctly. Let's dive into this. This video will be divided into two parts. First, we'll just talk about numbers, and then we'll talk about equations and how to format and put these in professional documents. All of this, and I have found the best resource for describing this, is the Chicago Manual of Style. And there's a whole lot more information in that manual than I can put here. I'm just hitting things at a high level and touching on what I see are the more common mistakes. But there's a lot more to this, so please obtain the Chicago Manual of Style if you're ever going to give presentations and produce professional documents that have numbers and equations in them. Numbers. The first thing we should talk about is a decision on when to spell out a number versus when to write it with its number digits. And the rule in the Chicago Manual of Style is to spell out all numbers 0 to 100 and then certain round multiples of those numbers. So for example, 500 would be written out. So an example sentence here, 37 people in 12 tribes attended the meeting. All of these numbers were spelled out because they were 100 or less. Now in STEM, when we produce professional documents, very often these numbers are not just a simple count, but the result of a measurement or calculations or things like that. And this Chicago Manual of Style presents an alternative rule where you only spell out the single digit numbers. And this is the one that I see most commonly in STEM and what I think is most effective. So I have two examples here. One, the first sentence, 37 people in 12 tribes attended the meeting. So 12 is not a single digit number, so it's written out as 1, 2. But then you might look at this 37. That's definitely not a single digit number. Why did I spell that out? Because it's convention when the sentence starts with a number that it is spelled out. So if you don't like spelling out large numbers like that, figure out how to reorder the sentence so it doesn't start with a number. And then the second example, the pencil was measured to be 5 inches. And notice there's a space between the 5 and the inches. Now I chose to put a number in here because this is an actual measurement, right? It's not just a simple counting number. Ordinals. So ordinals are words like first and second and how to write the ST and the ND on words like this. The Chicago Manual of Style says never use these as superscripts. So here's the example, Jimmy won second place. And actually, when I type this into PowerPoint and even Word, by default, it makes the ND a superscript. And the Chicago Manual of Style also says that's a mistake, and it should just be written as a 2 and an ND that's not a superscript. I recently published a book with Artech House, and they also required this style. This seems to be the most professional style, and after examining it, I think it also looks the best because anytime you have small letters, you risk it not being visible or getting washed out or something else. So I might ask the question, what if there's a variable there and not a specific number? Well, in which case you italicize that variable. So here's a sentence, the ith layer of a device was analyzed to the nth degree. So notice what I'm doing here. I have an italics I and an italics N. And the TH is not a superscript. Scientific notation, what's the proper way to write this? Well, scientific notation is a form of an equation, and equations should be formatted as if they're sentences. So the numbers are words. So the 4.678111, that's a word. Times is a word. 10 to the fourth is a word. Meters is a word. And we separate words with spaces. So we need those spaces there. And notice this M is the unit. It is not italicized because later we'll talk about this. Only variables should be italicized. And M is not a variable, it's an abbreviation for meters. Numbers and units. This is a super common mistake that I see all the time. Remember, interpret these things as parts of a sentence with separate words, and it makes a little bit more sense that a space should always be inserted between the number and the unit. Now, sometimes there is a hyphen. I have two examples here. A 200-watt bulb was used. So in this case, both 200 and watt are sort of adjectives that describe this bulb, but the 200 is actually applied to the watt, not the bulb, so it gets a hyphen here, just as you would do with actual adjectives that weren't numbers. And here's a second example. Sally was 65 inches tall. Must put a space here because 65 and inches are two separate words. Sometimes you need units that don't have a number. These units are always spelled out. For example, the voltage was measured in millivolts. I didn't say the voltage was 3.7 millivolts, in which case I would just use the MV. But there's no number here. I'm just talking about the units, so they must be spelled out. Now, sometimes the units are actual abbreviations. And here's an exception where we don't put a space between the number and the unit. So I have three examples here. One is percentage. There's never a space between the number and the percent sign. Temperature. There is no space between the number and the degrees F. Or 6 inches. There's also another notation where a single apostrophe will be 6 feet. That is an abbreviation for feet or inches, so there is no space. Fractions. Do we spell them out or do we write the numbers? Well, simple fractions, it's more formal to spell them out and in fact hyphenate them when they're nouns, adjectives, and adverb forms, which is most of the time. So simple fraction are things like 1/2, 1/3, 3/4. So let me just have some examples here. He dropped 3/4 of the papers. 3/4 is spelled out. The vote requires a 3/4 majority. Again, 3/4 is spelled out, and both of those examples are hyphenated. The quantity pi can be approximated as 22/7. I did not spell this out because this is not a simple fraction. So this should be inserted in number form. And something else we'll see later, this is also a horizontal fraction. Fractions in line with text should always be horizontal and not vertical. Now here's a case where we're not hyphenating, but we are spelling it out. The pizza was cut into 4/4. But notice a difference when you say 4/4 as opposed to something like 3/4 or 1/2. Repeated quantities. So we come up with repeated quantities usually when we're specifying a range, like in the example here, 50 degrees to 90 degrees, or specifying areas or volumes where we might have, 6 foot by 10 feet. So any kind of time where we have multiple measurements and each one has a unit, we have to make a decision whether to write the number and unit each time or to write the unit only at once at the end. And the rule is we keep the unit associated with each number if it's an abbreviated, if there's no space there. So from a previous slide, we saw that for temperature, there's no space because degrees F is an abbreviation. And so we would repeat that for every number that gets repeated. Another one, 6 foot by 10 feet. When we're using the abbreviation, the double apostrophe, we write a double apostrophe with each number. Also notice there's a space here because this is a sentence. 6 feet by 10 feet. Now we can write this sentence the exact same way, but without the abbreviation with the actual unit feet. Now in this case, there's a space, So we do not repeat the unit for each of the numbers. We write it a single time at the end after a space. Dashes. Did you know there are 3 kinds of dashes? 2 are very common. The third, you might see more if you do legal documents. The first is called an EM dash. So letter M. The reason it's called a letter M, if you look at the bottom here, I'm showing an EM dash. It has the same width as the letter M. So it's an EM dash. So the EM dash is a somewhat informal way of replacing something like parentheses or colons or commas and gives some kind of pause or separation to a sentence. So here's 3 examples of the way we could say something. I like 3 colors, colon, red, green, and blue. We could also put those colors in parentheses. I like 3 colors, red, green, blue. And probably the least formal way to do this is I like 3 colors, red, green, blue. Now, even though I say this is informal, there is actually a purpose. If I did a comma here instead of the EM dash, then there's also commas that follow, and that maybe could get confusing. So the EM dash is used sometimes to not get confused when whatever follows that has other punctuation. Another type of dash is called an EN dash. Well, now you can figure out probably why it's called an EN dash. This dash is roughly the width of the letter N. And by the way, this is not the same width. It's a little bit wider than a hyphen that you might be thinking. And a hyphen is different than a dash. This is formal. And so this is used when we're between like times or dates or in indexing, like page 1 to 10 or years. So here's 2 examples that I have. I work 7 a.m. to 6 p.m. today. Notice there are no spaces on either side of this EN dash. Maybe you're specifying a range of dates, World War II, and then in parentheses, I have 1939, EN dash 1945. So this will be read 1939 to 1945. And then the rest of the sentence does whatever that's going to do. Interestingly, and I just recently learned this myself when I was looking this up, there is a third type of dash, and it's called a 3EM dash. And this is used when you're omitting information. And so as I'm understanding this is used in legal documents to omit names or places or things like that. For example, the case between 3EM dash and 3EM dash will start tomorrow. And somehow there's 2 names have been redacted. Sometimes also underscores are used or a big black brick. Equations. Before I say anything about equations, let me just say at the time of this recording, it is year 2023, and there is absolutely no excuse ever to type an equation without using an equation editor. All the formatting stuff that we're talking about, I shouldn't say all, a lot of what we're talking about, 80, 90%, the equation editor will automatically format for you. So in Microsoft Word, for example, we would click on the insert and pull up the insert ribbon. And at the far side, we see equation. So built into Microsoft Word, we can click on that. And now we enter an equation editor that will format everything properly and do everything properly. And even open source word processors and presentation software now have built-in equation editors. So never, ever not use an equation editor. Maybe some people are raising their hand and they use LaTeX. And that's fine because LaTeX has an equation interpreter in that. An overarching rule here is to remember that equations are parts of sentences. So it's a little tiny part of a sentence. And a lot of what we'll talk about will make sense if you think of it that way. So they have to have just as much grammar and be stated just as clearly as any other kind of writing that you would do. Let's pull up some examples. Here we see X with a greater than sign and Y, but this is part of a sentence and it should be read as X is greater than Y. A plus B equals C. One thing I see a lot are people not putting spaces between things. Remember, if this is a sentence, your variables and the operations and relations, these are words. Words have to be separated by spaces. So if I were to write this without spaces, this is what I'm actually writing. I don't even know how to pronounce that. Able to go see, or something like that. We need spaces because this is A plus B equals C. The Pythagorean theorem states that a squared plus b squared equals c squared, where c is the length of the hypotenuse. Notice I've put a comma here. That's because that would be the proper punctuation had we spelled it out all into words. There would be a comma there. Let's talk about the spaces specifically because there are some exceptions that we have to point out. So as we saw from the previous slide, A plus B equals C. If we're thinking of this as a sentence, there must be spaces between all of these words. Otherwise, it's all just jumbled together. And even just looking at it, it can get hard to read. While there are plenty of exceptions, I'll point out two big ones. If we have parentheses, notice there's no space between the 2 and the parenthesis, and there's no space between the parenthesis and the x. And over here on the right-hand side, no space between the parenthesis and the y. Exponents, so we have z squared. There's no space between the z and the squared. Maybe we have a matrix transpose, no space there. And I didn't do a subscript, but there's no space there as well. So there are exceptions to this. Use of italics. And I think of all the mistakes I see, this is probably one of the bigger ones. So we'll spend a little bit of time on this. But an interesting thing about fonts, when you're using a font that's specifically intended for math, because italics is so common, they design this so that the italic letters don't overlap each other. So they tend to be less slanted than in other font styles. So Times Roman is a really common font for math. I noticed that Microsoft Word in their equation editor, they use Cambria Math by default. Variables. The only thing in an equation that should ever be italicized are variables. So we do not italicize functions. We do not italicize things that are actually words. Some exceptions to this, for whatever reason, uppercase Greek letters aren't italicized. Don't criticize me. I'm the messenger. That's the convention. Also, if there's variables that are multiple letters, so they're more abbreviations, those do not get italicized. So here we have an equation for field of view. Field of view being abbreviated FOV, even though that's a variable and we'll have a number associated with it, it's not italicized because it's multiple letters. We have an uppercase Greek lambda, so that is not italicized. There's also a lowercase Greek lambda that is italicized. We have a lowercase theta, so that's italicized. A pi, that's italicized. Sine, that is a function. That is not italicized. Our parentheses are not italicized because parentheses are not variables. The sine function is not a variable. So if it is italicized, I'm immediately going to assume that it's a variable. Let's go through some examples. So cosine x, what is wrong with that, if anything? Well, if you've been paying attention, the x is the only variable here. That is the only thing that should be italicized. Cosine should not be italicized. All right, cosine x, what is wrong with this? Well, cosine's fine, but x is a variable. It should be italicized. Next example. So k is 2 pi over lambda. What is wrong with that? Well, we have an uppercase Greek lambda that's been italicized. And for whatever reason, for a reason I don't know, that should not be italicized. Next example, the Shannon capacity theorem. What is wrong with this equation? Don't even need to describe what the equation means. Well, it turns out there's 3 things wrong with this. C is a variable, and it should be italicized. Bandwidth is a variable, but it's multiple letters. It should not be italicized. Signal to noise ratio is a variable, but it's a multiple letter variable and should not be italicized. So the correct way to write that equation is shown on the right here. Next example, P average is A squared over 2. What is wrong with this, if anything? Well, the subscript, we have an italicized A, V, and G. That means that A, V, and G are 3 different variables being multiplied together. Well, really, we just meant to say average. That's some sort of abbreviation. Well, that should not be italicized. Now, the P should be italicized. It is a single letter variable. A should be italicized. Along the lines of using an equation editor, you should never, ever, ever type your parentheses or square brackets or curly braces. And there's a reason for that, because there's sizing and spacing that needs to happen here. So here I've just typed cosine x, even though I went back and I did a nice italics x. So this looks correct, but look at the difference when we use an equation editor. There's a little bit more white space, and the parentheses are also bigger around the x. Now we might look at this and say, okay, that's not such a big deal at all. And you're right, I could probably get over that. But look what happens when you put a fraction inside of those parentheses. These are typed so they don't grow with the equation inside of it. Whereas equation editors, if you insert parentheses or square brackets or curly braces, they will grow with whatever's on the inside. And if you ever have nested, like parentheses inside square brackets, everything's going to grow and the sizing's going to be correct. If you're just typing these, that's not going to happen. Now, sometimes equation editors are smart, and if you type parentheses, it's smart enough to say, oh, okay, that person doesn't really want to type a parenthesis. They actually want to insert this new equation inside that, and it will automatically recognize that and insert those parentheses properly so that they grow in size around whatever's inside of them. Another word of caution, always use the correct math symbols. Multiplication is confused so many times. I teach electrical engineering, and so these are the types of multiplications that we tend to use. So if we write 2 variables side by side, that's an ordinary multiplication. For whatever reason, sometimes we just like the space or whatever, we can insert a small dot, and again, that is an ordinary multiplication. But when this dot gets big, that's actually implying a vector dot product. Or a lot of people like to write this little X symbol for times, and that's actually a vector cross product. This stopped being a time symbol somewhere in grade school as soon as we started learning vectors and stuff like that. So I would avoid this at all costs unless you're doing something for grade school as being ordinary multiplication. That's a vector cross product. And this isn't quite an asterisk, but it's a little star. It's a convolution operation. And there's many other symbols, but each of those has a very specific meaning. And in electrical engineering, we also have this convolution. So don't mix them or it gets very confusing. Wrap around equations. Suppose we have an equation that just can't fit on one line. What we don't want to do is type it all in one horizontal line and shrink it down until it fits, because the font can become too small and you'll either violate your formatting guidelines or it just becomes unreadable. And so what we'll do is we will just simply wrap the equation around to the next line at whatever point makes sense. Here we have these 3 dots. The 3 dots is not what is indicating that we're going to the next line. It's actually indicating that this series keeps continuing. When we do wrap around to the next line, we have to think about the justification of it. Not justifying why we do it, but the justification and how we're aligning this. So if there were no pi 4 equals and the 1/2 were the first term, we would look at the left half of that and align everything with the 1/2. When we do have the pi 4 equals, we're not going to line up to the pi over 4. We're going to align everything to this first term to the right of the relation, the equal sign. And so that's how we align the wraparound. Now, if this were the last thing in a sentence, then we'd have a period at the end. And the period is not sort of a mistype. It's not meant to be one of these dots. It's even at a different level. It's there because this is the end of a sentence. If it were intermediate in a sentence, maybe there'd be a comma there or nothing at all. Inline equations versus breakout equations, maybe where they get their own separate line like this A greater than B. And the rule is, if it's just an incidental equation or a small equation that's part of a discussion, it really should be put in line with the text. You only want to break out to a separate equation if the equation's way too long to be practical to put in line with the text, or if it's an equation that is critical to whatever it is you're describing. So my example here, under the condition A greater than B, the value of C can be approximated as, and then I give this final equation. The problem with that is the A greater than B is just too incidental to warrant having its own breakout equation. So we wouldn't want to do that. So what would this look like more correctly? Well, under the condition A is greater than B, the value of C can be approximated as, and we only have one breakout equation now. Fractions, specifically, when do you use horizontal versus vertical fractions? If you're writing a breakout equation, vertical fractions is the way to go. Horizontal fractions is most commonly used and most properly used when you do inline text. So for example, I might have this bit of text and I have an equation in line, and it's probably just an incidental equation, so I don't want to have it be its own breakout equation, but I have this 2 pi over lambda and I'm doing a horizontal fraction. And you might wonder, well, why not vertical? Well, let's look at what happens when we do this vertical. The spacing between the sentences becomes more, and this can look ugly and awkward. So inline equations should always use horizontal fractions. If there's something complicated enough about your equation that you need the vertical fraction, well, then maybe it needs to be a breakout equation. Another thing is when the fraction is used in a superscript or subscript. For example, x to the power of a divided by b. That wouldn't be proper. That exponent should be in horizontal format, a/b in the horizontal formatting.